Did you know that without a solid project structure and a properly configured Kubernetes cluster, your app won't even get off the ground? In part 2 of this series, we're going to show you how to build that foundation, from setting up folders and key files to creating your local cluster with Kind and installing the NGINX Ingress Controller, all in a hands-on way. If you haven't watched part 1 yet, I recommend checking it out first. That's where we introduced the project and explained how Ingress fits into the big picture. But if you're ready to move forward, our expert Herbert Pereira is taking over to get your environment up and running. Let's keep building. This series is just getting started.
Hello and welcome to part 2 of this special edition of Kubernetes Ingress with Kind. In this second part, we are going to create the project structure which corresponds to the folders and files we need in order to successfully proceed with the next steps of this hands-on experience. Additionally, we will create a cluster using Kind, and we will also deploy the NGINX Ingress Controller. To accomplish this, I'm going to use AWS Cloud Shell to create a script with the following command. This will generate a script called install tools that will install and configure Docker, kubectl, as well as Kind, ensuring that all the necessary tools are properly set up for our environment. Now, if we list the files, you'll see the script that I will use to create an EC2 instance on AWS. This instance will serve as our environment for executing commands and deploying our infrastructure. In this step, we are creating an instance with the size t2.medium and naming it Kind host. The EC2 instance will utilize the script we just created by including it in the user data field, ensuring that all necessary tools are installed automatically upon launch. After running the command to create the instance, you can press the Q key to exit the output. Once that's done, refresh the AWS console and you'll see that a new instance has been created and is running all through the AWS CLI. Let's wait for the EC2 instance to become ready. Let's go ahead and refresh the console once more. As expected, the instance is still in the process of being created and initialized. It may take a moment before it becomes fully available with all the tools installed and ready for us to use. Once the process is complete, I'll have my machine ready to go. There are several ways you can access this machine using an SSH connection. I'm going to use VS Code with the SSH Remote Explorer extension to connect, but you can also conveniently access the instance here through the browser connection itself if you prefer. I'm going to make the connection to start the process of creating the structure of the project, and I'll be right back. I'm already logged into the brand new instance that we've just created, and now we're going to run a command that will automatically create the complete directory structure we need for our project setup. Then, by using this command, it will automatically create all the necessary folders and files for our project. I'll have exactly the structure I showed you earlier. Our applications files will be organized into a dedicated folder, and the application itself will be divided into 3 main parts: the home, the products, and the checkout section. Each application component will have its own set of files, including an index file and a Docker file. The Docker file will be responsible for building the image for each individual component, ensuring that everything is properly organized and ready for deployment. We'll also have the file that will create the cluster, which will be created precisely in this video, as well as the folder with the manifests, which are the YAMLs files that will be responsible for doing the deployment part, which will be responsible for creating all the pods, and the containers will be executed inside these pods. We'll also create the ingress, which will be the icing on the cake here at the end, so that we can have external access to our application, and there will also be the services that will communicate with the ingress. Right? As we clear the screen here, we can see that the file structure we showed you in the project has now been properly created. Let's go ahead and create the file that will be responsible for setting up our Kubernetes cluster. We already have the file that was generated with the previous command, and now here we have the YAML code that will define the complete configuration for our Kubernetes cluster. We're going to create a cluster using Kind, and this cluster will be named Ingress Cluster. It has already been configured in advance so that it can support being an Ingress-enabled cluster, meaning it will be ready to host a special pod. The Ingress Controller. How many nodes will this cluster actually have in its configuration? It will have only one, which will serve as the control plane. This node is already configured to accept incoming communication on both 80 and 443 ports. The host port mapped to the 8080 port will allow us to access this application directly from your local machine or browser. Well, once we've created this file, we're now ready to proceed with creating our cluster. Before doing that, let's quickly check which folder I'm currently working in. If we run the Kind get clusters command, we'll be able to see a list of all the existing clusters that have already been created and are currently available on our system. However, we don't have any clusters created yet. Let's create a new cluster. All we need to do is run the kind create cluster command and specify the configuration file we'll be using. In this case, we'll use the kind configuration YAML file that we just prepared, which will automatically set up the cluster with the control plane node according to our specifications. Remember that this cluster will only have a single node, which is more than enough for us to demonstrate in practice how to set up and work with an Ingress controller. This scenario is ideal for hands-on learning and testing. And now the process begins. Kind has already connected to Docker Hub and downloaded the required kind node image. You can see from the specific image version. It is preparing the node, and you can see only one container displayed here. If the cluster had more nodes, you would see several container icons. It's a very clear and visually appealing presentation when you create a cluster with kind. Once the cluster creation process is complete, we'll rerun the command that previously showed no clusters had been created. This time, when we execute the command again, we'll see that our new cluster has been successfully created and is now listed. And it does all the configuration for the control plane, the network communication, and the storage cluster, so it creates everything we need. So now, if we rerun the kind get clusters command, we'll see that a cluster has been created. We've installed kubectl, which now allows us to efficiently interact with and manage all the Kubernetes components within our cluster. So now, if we run kubectl here, we'll see that we only have one node, and this node is of the control plane type. And now, let's move on to our next important step, which is to install the NGINX Ingress Controller in our cluster environment. To perform this installation, we already have a YAML file, a ready-made manifest, which allows us to quickly and easily deploy the Ingress controller. So we're going to use exactly this manifest, which will automatically set up an NGINX Ingress controller, complete with all the necessary permissions, components, and roles required for it to function properly in our cluster. So, as it's a special Kubernetes pod, it has all these specifications, properties, and features. Now let's go ahead and run the kubectl apply command, passing in the specific file that we want to deploy to our cluster. So we'll use kubectl apply, providing the URL that I've previously shown you to start the deployment process. The deployment process may take a few moments to complete. To help with this, we can use the kubectl wait command, which will wait until the NGINX Ingress Controller is fully initialized and actually ready for use in our cluster. The ready flag is the condition that indicates when this Ingress Controller pod is fully prepared. Once it is ready, the terminal will be released and we will be able to check its status. We'll also be able to see how many pods are running inside this specific namespace, the NGINX Ingress Controller namespace. So, if we now run the kubectl getPods command using the N flag to specify the Ingress Controller namespace, we'll be able to see that the NGINX Ingress Controller has already been successfully deployed and is running in our cluster. In the same way, we can also verify that the service has already created a load balancer service, as well as the cluster IP service, which is responsible for enabling internal communication between the various Kubernetes components. Alright, that concludes part 2. In the next video, we'll configure all the application files, build and upload the images directly to our kind cluster. See you.
Alright, thank you so much for watching this video. And then if you enjoyed this content, please consider subscribing to our channel. Give us a thumbs up if you enjoyed this content, and then also please leave us a comment telling us what you think about this video and also the things that you'd like to see in a new video here on our channel, okay? And then if you're interested in mastering multi-cloud DevOps and AI with our help, please check the links in the description as well. Hope to see you in the next video. Take care and goodbye for now.